We are starting with number 7 now. A train travels with a speed of 60 km per hour from station A to station B and then comes back with the speed of 80 km per hour. This time it's coming faster from station B to station A. Find the average velocity and find the average speed and the average velocity of the train. So you can see as the train comes back to the station A, my displacement will be 0, hence the final hence the displacement as the average velocity will be 0, but we need to calculate for the first section, which is the average speed. So I've done it here, number 7. The first velocity given to me was 60 km per hour and the second one is 80 km per hour. Let the distance between the station A to station B be S, because the distance remains same whether it is going from A to B or coming back from B to A. So while coming back from station B to A, let the time taken be T2. The first case the time taken is T1. Because the time taken will be different because the speeds were different. You are supposed to find the average speed. The formula for average speed will be total distance by total time. So I need to find the total time. So that means there are two times in this case. First while going from A to B and then while coming from B to A. So from A to B I have taken the time to be T1. So the T1's value will be S upon V. Here I am not using the equations of motion. So why am I not using the equation of motion? Because it is uniform speed or uniform velocity. See, whenever the body is moving with a uniform speed or uniform velocity, we are not supposed, there is no acceleration, so there is no use of using the equations of motion. There is no point of using the equations of motion, so we can directly use the formula which you have studied in class 7. And then if there is any involvement of acceleration, then we are using the equations of motion, provided the acceleration is uniform again. So using the formula for time, which is distance upon speed, I am getting S upon 60 km per hour. And then second case for the time T2, I am getting again using the same formula S upon V2, which will come S upon 80 km per hour. So the average speed will be total distance by total time. So total distance is S plus S, total time will be T1 plus T2. So replacing the values of the time, which is T1 and T2, so S plus S will give me 2S upon S upon 60 plus S upon 80. Here 2S, that will be equal to 2S upon, I'm supposed to find the LCM, which is 240. So 2S upon 4S plus 6S upon 240. By finding out the LCM, I'm getting these values. Okay, 4S plus 3S. I hope you all know this. Then again, further solving it, I'm getting 2S upon 7S, 4 plus 3, which is 7S, multiplied by 240. So S and S gets cancelled after solving it, or after doing the multiplication and then division. I'm getting 68.57 km per hour, which is our average speed. I haven't done for the average velocity because the average velocity will be 0. Why? Because the displacement is 0. So we can go to number 8 now. Question number 8 reads as: a train is moving with a velocity of 90 km per hour. It is brought to stop by applying the brakes. So initial velocity given to us is 90 km per hour and the final velocity given to us is 0 because it comes to rest. Now if we go to the things which are supposed to calculate will be which produces a retardation of 0.5 meter per second square. It produces a retardation as well, which is 0.5 meter per second square. Find the velocity after 10 seconds. So I am supposed to find the velocity after 10 seconds. Before it comes to rest, it should have some velocity less than the initial velocity. So I'm supposed to find that, and then I'm supposed to find the time taken by the train to come at rest. So this was question number 8, and then I've solved it here, number 8. So question number 8, there are two questions, two parts, number 1 and number 2. First thing, initial velocity is 90 km per hour. I'm supposed to convert it into meter per second by multiplying it by 5 upon 18. After cancellation and then multiplication, I'm getting 25 meter per second. Again, my v is 0, and when my retardation equals to minus 0.5 meter per second square, I have used a minus sign because it is retardation. So number 1, v after 10 seconds. So we have time, which is 10 seconds. We have initial velocity, which is 25 meter per second. Hence I'm able to use the first equation of motion, which is v equals to u plus at. Replacing those values, I think I don't have to tell you how to solve it now. We've been doing this solution many times. So again, replacing the values and then again multiplying and then adding and then cancellation, etc., I'm getting 20 meter per second. I hope you are able to do this by yourself, the calculation part. Number 2, when the velocity is 0, I'm supposed to find the time. Again, I can use v equals u plus at, and velocity is 0. Initial velocity was 25 meter per second, plus with the bracket open minus sign. Why minus sign? Because it was retardation. 0.5 meter per second square multiplied by time. And then doing the solution, I hope you know how to do the calculation by now. Doing the solution, I am getting t equals to 50 seconds. So I hope you know how to do the calculations. Please do it by yourself. So I'll help you a lot. This was number 8. Now in the next video we shall do number 9.